About 500 light-years from the Earth, a star named Betelgeuse is on its deathbed. This star is so big that if it were present at the center of the solar system, in place of the Sun, its outer edge would be close to the orbit of Jupiter. The supernova that would result from the implosion of this supergiant star would be visible even during the daytime for a couple of weeks. In 2020, Betelgeuse made it to the headlines because of its mysterious dimming. Since it lies cosmologically close to the Earth and has reached the end of its life, the star is regularly monitored by various Earth and space telescopes. Lately, it's not just the astronomers who are excited about Betelgeuse. Even particle physicists, who study the universe at the quantum scale, are looking up at this red supergiant. What is it that Betelgeuse is hiding in its extreme environment? And why are scientists so excited about it? One of the most significant unsolved problems in astronomy is that of dark matter and dark energy. Everything that we see in the universe, from the smallest particles to the largest galaxies, is made up of ordinary matter. The problem is that it's just 4% of what's there in the universe. About 96% of the observable universe is composed of dark matter and dark energy. We have no idea what it looks like, but we know something's there that's eluding all our efforts to hunt it. We know it exists because can measure its effect on ordinary matter. Since everything we see around is composed of tiny particles, scientists think that there might be a dark matter particle, responsible for the unaccounted mass of the universe. There is not one, but several particles proposed as dark matter candidates. One of the most promising is the axion, theorized way back in 1977, to solve a completely different particle physics puzzle. Astronomers think that the fiery core of Betelgeuse might be a factory of axions. Here's what theory says: the particles of light, known as photons, can change into axions, the proposed particles of dark matter in the presence of a strong magnetic field. Once these axions escape the star, they can again interact with our galaxy's magnetic field and change back into photons, but this time as X-ray photons. Since Betelgeuse is an old star, it isn't expected to produce copious amounts of X-ray photons. So if we detect unusual levels of X-rays from Betelgeuse, it might be a sign of dark matter particles. A team of astronomers made several observations of Betelgeuse. Although no signs of unusual levels of X-rays were detected, scientists concluded something important. The photons are at least 3 times less likely to interact with axions, in the ways thought earlier. Axions are believed to be up to 1 billion times smaller than an electron. Detecting these tiny particles in the noisy environment of Betelgeuse is not easy. Even if X-rays are detected, scientists would have to rule out several other possibilities, before concluding that dark matter particles produce them. If or when axions are detected from Betelgeuse, it would not only be a breakthrough for particle physicists, but also for astronomers. That's because this discovery would help us understand what's going on in the core of this supergiant star, and we might finally be able to calculate the time left before Betelgeuse undergoes a supernova. The supernova of Betelgeuse is one of the most awaited astronomical events. The most recent supernova to be seen in the Milky Way galaxy was observed on October 9, 1604. We didn't have the advanced technology to understand what was happening. But today, we are well equipped with telescopes on Earth, and in space, that will study the behavior of light emitted from the explosion and the stream of different particles emitted.